All right, so for the first couple of videos, we were just talking about simplifying expressions. Now we're going to go through and prove that identities. The big thing to remember about this is that you only work with one side of the equation. That's it. You absolutely cannot work with both sides of the equation at one time. So we're taking all of the different things that we have done and we want to transform one side of the equation into the other. So let's go ahead and just jump right on in and look at a first example. So if I have the sine of theta over the tangent of theta, I need to prove it is equal to the cosine of theta. Now, again, always pick the more complicated side to start with, and then always look at what you want to end. We want to end here. This is our goal. So if I'm looking at this, the first thing we want to do is, because that is only the term cosine, we want to use that first big idea of changing everything we have into sines and cosines. So if I do that, then I will rewrite this as the sine of theta divided by, instead of saying the tangent of theta, I know the tangent is the sine of theta over the cosine of theta. And this is our fraction face-off. We want to go ahead and keep change and flip this fraction around. So I have the sine of theta. Instead of dividing, I now multiply, and I multiply by the reciprocal of the tangent over the cosine of theta over the sine of theta. That cancels, and that proves that the sine divided by of theta divided by the cosine of theta is equal to, it proves that the sine of theta divided by the tangent of theta is equal to the cosine of theta. All right, that was a pretty straightforward one. Let's go ahead and look at one more. All right, so my second example here that I have is cosine of x times the secant of x all over the tangent of x. Now, I need to try to prove it is equal to the cotangent of x. So what I see when I'm looking at this, I have a tangent in the denominator. So I'm going to leave this tangent alone. That's what I want. But what I'm going to do in the numerator is I'm going to take and use the reciprocal function of what I know that secant is equal to. I know the secant is equal to the cosine, and then that secant I go through and replace, and I make that 1 over the cosine of x. This is all over the tangent of x. So what is a cosine of x times the secant? Well, it's 1 over cosine, so all of this just equals 1 over the tangent, of x, which is equal to 1 over the tangent is my cotangent of x. So we got that one. We're all set. So now we're going to go ahead and look at question 3. Question 3 has the cosine of theta all over the secant of theta times the sine of theta. And I need that to equal the cosecant of theta minus the sine of theta. Now, this one gets a little bit more involved, but what I want you to see with this is there's a product here in the denominator, the secant times the sine. So I'm going to break this up. Remember, this is just multiplication, right? So because that is multiplication, look what I can go through and do here. I can rewrite this as 1 over the secant of theta, right, times the cosine of theta over the sine of theta. And I can do that because if I multiplied them together, I would get exactly the same thing. Now, why did I do that? Well, I did that because I wanted to go through, and I didn't like that cosecant, the secant here. Excuse me. I want to write that 1 over the secant is what? 1 over the secant is actually the cosine, correct? That's a cosine of theta. Now look what I can do with this. I have this times the sine of theta. So the first thing, in essence, what I did here is I churned everything back into sine and cosine. Now, that's helpful because I know that the cosine times the cosine is equal to the cosine squared of theta over my sine of theta. Again, keep in mind what I'm looking at. You see how I have 2 different pieces in my end result? My final solution that I'm trying to prove here is 2 terms. I don't have that right now. I need to somehow make that. Well, what do I know the cosine is equal to? That's my Pythagorean identity, right? The cosine is just equal to 1 minus my sine squared of theta. This is all over my sine of theta. So now if I go through and break this up, I have my 2 different terms. I have that this is equal to 1 over the sine of theta minus the sine squared of theta over the sine of theta. Well, guess what? We're done. Because 1 over the sine is equal to the cosecant. And this, remember, sine squared is the same thing as the sine of everything squared. I can subtract 1 piece there. So this is just the cosecant of theta minus the sine of theta. And I just proved that identity. All right, let's go ahead and try another one. Let's go ahead and look at cosine of x over my secant of x. This is number 4 in the class notes. Cosine of x over the secant of x plus the sine of x over the cosecant of x. And all of this is supposed to equal 1. All right, so first thing I'm going to go through and do with this is turn everything back into sine and cosine. So this first part stays as the cosine of x divided by the secant of x, and the secant of x is just 1 over the cosine of x. Leave this as the sine of x over the cosecant, and the cosecant is the same thing as 1 over the sine of x. So even though this one looked fairly difficult, what happens when we get this? This is that keep, change, flip. This is cosine of x times 1 over the reciprocal, which is the cosine of x, plus sine of x. Again, I flip my reciprocal, so I multiply that times the sine of x. So cosine squared of x plus sine squared of x. That's my Pythagorean identity, right? And I know that all equals 1. So we'll do one more in this example of proving the identities. What I will tell you with this is it takes a little bit of practice with this. If you go back and look up in the rules that I have at the very top when I started this, rule number 6 says if after a few minutes you're not getting anywhere, stop and start over. Try a different technique. and because it just takes a little bit of practice. All right, so for the last one I'm going to do with you here, it's going to be 1 plus the tangent of theta all over tangent of theta is equal to 1 plus the cotangent of theta. Now, again, as I'm looking at this, I'm looking at the back piece here, and I see that where I'm trying to go has two terms. I also see one of those two terms has the cotangent in it, so that's what tells me to go ahead and deal with my fractions, and this time I want to split them. So I want to break them into two different denominators. One of them will be 1 over the tangent, and then the other one will be the tangent over the tangent. So what I'm left with is 1 over my tangent of theta plus tangent of theta over tangent of theta. And I can do this because if I were to common denominator, if I add those two fractions together, I'd end up with the same thing. Well, what is 1 over the tangent? 1 over the tangent is the same thing as equal to the cotangent of theta, and tangent over tangent is just equal to 1. And that is the last identity for us for this video. You do want to make sure you do the identities, the simplifying trig expressions, and the identities for 4.1. All of the solutions are posted online. And again, if for any reason you get stuck while you're working on these, go ahead and just start over and start a different technique.